Welcome back to Ox Tools. I'm Tom. So tonight we got the final installment, number 4, of setting up and cutting short machine tapers. So from the comments and the questions, I think this has been a pretty good series. We're actually going to wrap it up and actually machine Kurt's drill press shaft and get it packed up and send it back to him. So he's been very patient and about getting his shaft back, but it's been a good, it's a good solid discussion. It's tapers and cones and fitting those things together is a big subject, and we've just kind of scratched the surface here. There's a lot more to it. So as these things come up, maybe we'll do some more. But anyway, let's get an apron on and let's hit the shop and let's machine a drill press shaft. Okay, so we're gonna go ahead and test this shaft for straightness here, and just gonna zero the indicator here, and I'm just gonna come across the top of it and make a little adjustment there. All right, so the V blocks are your 0 points. Try to get it zeroed up on that. Okay, over here, check that, and that agrees. Okay, and then what I'm going to do is just kind of check a few spots along the length of it here, and what I'm looking for is, you know, how straight this thing is, basically. So, all right, and then out near the tip here, where our taper is. Okay, it's a little different there. All right, and then what you want to do, okay, that's all fine and dandy. We're just going to rotate it a little bit. That still agrees. And so you're just going to do that process a few times. Okay, so there's, what is that, a half thou? Yeah, it's about a half thou right there. All right, let's rotate a little more until you basically find the you know, the mins and the maxes here. All right, this section looks pretty good there. Okay, let's rotate it a little more. So we got a little something going on here at the tip. Yeah, about a half. There's a little bit there. Now I can't check out at this end here because it's full of splines. Spines or splines? Spines. You know what I mean. It's splines. Okay. So we're just going to go around this thing and then check it until we're satisfied that we've seen all the its anomalies. Okay, so about a half. So, oop, there's a little something. 3/4 of a thou, something like that. Basically, what I'm seeing here is just this shaft is actually pretty straight, which is good news for 3/4 there. All right, so in general, it's pretty good. Let's do one more. Okay, so we're back over here on the lathe looking at looking at some more indicator glare. So I found something else. Oops, almost knocked it off there. That I've been playing around with here, and it's this window glare film, or window film for glare control. It's made by Gila or whatever, and this came from Lowe's, I think. And I'll tell you, this is a kind of a lifetime supply here, but at least for indicators and stuff. But what's interesting is it's not a hard film, and I've cut some circles out. You can see it's kind of soft. It's kind of gelatin-like, but it actually kind of works, but it conforms to the curved face. Now you're getting a little reflection there, and if I just tip it a little bit, you know, that still doesn't work, right? But if I tip it just a little bit, the surface of this works pretty good. So, look in the camera there. Yeah, you can see the needle pretty good, actually. So this is kind of workable here. It's a little dark. I may try to see if I can find some that's a little bit lighter than this, because I don't think it needs much. And then now this is this neutral density filter. And I have to say, you know, there's about 20 guys that said, just put it in front of the camera, right? Well, that doesn't work, okay? The camera just adjusts the exposure, all right? It doesn't work. So, anyway, that works pretty good too, all right? But this doesn't have any adhesive on it or any way to retain it. This has that kind of peel and stick. Well, it's not even sticky. It's just kind of vinyl-y, and it wants to kind of suction cup on there, so it works pretty good. So if I can find some that's a little lighter, that might be the kicker. So I think I'm going to see if I can bump into a window tinter or something like that and get a little piece of pretty light stuff to experiment with. Anyway, so that's kind of coming along. That's working a little bit, and so we're narrowing in on a material. Now I got this. Let me grab it. So this is the other stuff I got here. Was blowing out here. Oh, you can see that. This is this. It's an anti-glare that goes on like a phone or a navigation unit in the car or something like that. And it's made by 3M, and it's this Vacuity screen protector, but it's an anti-glare. This really didn't do anything. It's really kind of not the right thing, and it's kind of, at least this particular stuff is pretty stiff. And let's see if, actually let's go ahead and show it on camera here. Let me get that off of there. And it's expensive. So yeah, this was 13 bucks for this little piece here. It's kind of a rip. So, you know, what is that? How many square meters is that? Okay, so it's 3 feet by 6.5 feet. That was 13 bucks. Okay, also. So it just kind of puts it in perspective. So there's the stuff there, and it doesn't really do much for us. Let's see. Okay, so this is interesting because it's an engineered material here that has kind of little cylindrical features on it, very, very small, that are supposed to cancel glare, I guess. But guess what? It doesn't work for this particular application. So it may be fine for screen displays, but it's not good for indicators with too much light on them. All right. Anyway, I just thought I'd share that with you guys. That I'm still playing around with this because I want to solve this problem for both of us. You know, for me and you, so I can see my indicator, the thing stays on, and you guys can read it, because I know you don't believe me when I say it's not moving, right? Okay, so finally we're doing the real McCoy here. So let's get this thing dialed in there. There. getting close now. So I'm hoping you guys can see the indicator okay. This is this Gila film that I was talking about the other day. It's under 1,000 there. I think that's it right there. Okay, let's make sure they're all kind of equal. All right, that's pretty capital P there. So let's get this out of here. All right, so first step here. First step is we're gonna turn this to the major target diameter, which is 625, 624, and then we'll face the end, and our compound is set at a good angle from the previous video, and then we're just going to turn our taper, and we'll do a little checking on it and see how we did. Okay, so I've turned a little bit off of there, and what I'm looking for is a circle that's just big enough to do what we want to do, and that's about 9/16 of an inch, so it's 561 or something like that. So we're about a 1/2 inch right now, so we're going to face a little bit more off until we get a diameter that's, you know, a shade bigger than our minor diameter. Let's take a look at that. That looks pretty good, actually. Actually needs to go a little bit more. What do I want to do there? I think I'm just gonna open it up a little more till it's there. So I'm just cleaning off the weld buildup that was on the end to repair the damaged shaft. That's pretty good. That's probably 530 or something like that. Okay, I think I'm going to do a little diameter turning here, and then go from there. I'm just trying to find a high spot here. Like a pretty good cleanup there, so I can get a measurement. So we got, yeah, look at that. So you can see where the weld material kind of is built up there. So looks like I can get a measurement. $669, 6693. 0.6693, enter. Okay. All right. Well, now I know where my tool is. 640, something like that. Looks like, okay. All right. Okay, well, it's tracking properly. Yes, okay. Happy with that. Okay. Pretty lumpy looking, huh? All right, so that should be around 630 there. So we get, I don't know, 6 thousandths to go. I think what I'm going to do, since I'm worried about finish on this, is I'm going to switch over to a high-speed tool that we had a little bit better luck with on this. Well, actually, that feels pretty damn good, man. It's smooth, but yeah, darn it. So I think, you know, this filler material is 70,000 PSI filler material, so it's a little harder, so we're a little stronger, so it's cutting a little bit better than plain mild steel. So I'm tempted to kind of go with it because it's looking pretty good. I don't know, let's try a test cut with the high speed and see if that makes a difference there. So I'll take a few thousandths with this. Alright, there's a pickup. I'm just going to dial in about 2 thousandths or so. See if we get a better finish there. It's looking pretty good. I think we got to go with that one. Okay, so let's get a measurement. We'll recalibrate tools here. 6283. All right. 0.62283. Enter. Okay. All right. Yeah, it's leaving a superior finish there, so let's just go with that. All right. I'm going to change up this shot here.
Get a measurement on that. 625, right on the bean there. Okay, so better to leave it a whisker big there, because we're coming up to a corner, so it's pretty easy to polish that off. All right, so now what I don't want is, yeah, we got plenty of meat there. So I'm going to calibrate the front of the tool on that face. I'll take a little bit more off of that face, and then we'll start our tapering operation there. Okay. Check that diameter. Go a little more. Kind of hard to tell with all that weld on there. Take another 10 off of that. Pretty close there. Okay. All right. I think I'm going to call that good. Zero up. All right. What else do we need here? So I think what I'd really like to have is I'd like to have a little scratch at 1 inch from that edge. So I'm going to get what am I going to get here? Maybe a little threading tool, and I'll come up and I'll give me a little scratch at 1 inch from that edge. Okay, so let's calibrate. We got a little threading tool in here. We're just going to come up and pick up that spot. Okay, so it's just got a hold of some 1 mil stock there. And let's give it a little 0. And the insert is, I forgot how wide these are. 79 thousandths wide. So is that 39.5? We'll move over half of the insert width, and I'm going to re-zero, and then I'll come up to my 1 inch. All right, come on, right there. Okay, I'm going to give it a little scratch. Let's do this. Okay, pretty definitive line. Okay, so let's do some taper turning here. Get that. I'll change the camera around and we'll go from there. Okay, so what I'm going to do here that's a little different than what we did before is we have our known upper diameter, okay? And we have a distance from our finish face to the end of the taper. So what I'm going to do is I'm going to work backwards. I'm going to turn backwards this time. And so I'll start here. I'll probably touch off a little bit, then I'll come back and remove all this stuff here. And then, you know, once I have a good fully clean taper there, okay, what this does is this allows me not to overshoot inadvertently, because how do I want to explain this here? Well, you know, I'm on the DRO, so it probably doesn't matter. You know, I could go either way on this. Yeah, with the DRO, I could go either way, and it's not going to make any difference. So, because I know what this diameter is here, so as long as I don't drop below my finished lower diameter here, then I should be fine. So let's just go for it. I'm going to back up to my 0 point. All right, and then I'm going to come in to some number. Let's try. We'll go 600. And then we're going to use the compound now to advance the tool. Okay, let's go. Pass, I'm going to advance in a little bit, and then I'm going to cut on the backstroke now. And these are roughing cuts, so it doesn't make too much difference right now. So you saw where that faded out. We just don't want to fade out past the fade out past our 1 inch mark. Zero on our compound. We're going to come in a little more. Come up to my 0 again. This is why you need actually, you know what? I'm going to do something here. That's why you need a 0 on the compound, is so that you can get back in the same place. I think it'll be easier for you guys if I do this. Kind of see what's going on here. Sharpie's going south there. So we're actually kind of getting close now. Just what we expect, which is good. It's always comforting. Moving up to my my Z starting position there. Okay, here we go. really nice. Quite. We need about another thou, and that's what the DRO says. I need about another thou. Come back here, past, come up to my 0. All right, come in. This is it, boys. Okay, so I think we're there, and I remeasured the upper diameter, and we're about 1/1000th big here, which is this is going to be okay for this. So this is the chuck that he sent me with the job here, and I don't know if you can see down inside that thing, but it's kind of a chowder fest down there. Although I did try it on here, and it kind of goes on. So what I thought. All right, watch out. All right, let's do this maybe. Okay, Mr. Wizard. All right, there it goes. What I thought we'd do is we'll stick it on there. I'm going to break this edge a little bit because there's the sample. This is the commercial sample. You know, it's got a little chamfer on there, and you can still see a little bit where the weld was. So I'm going to put a little radius on that and just kind of break that edge nicely. And then we will put this on. I'm going to put it on gentle this time. And then we're going to we'll put a pin in here. And like I said, this chuck's a little chowdery, so, and then we'll put an indicator on there and see what we get. It may work for him, I don't know. I would suggest buying a new chuck because this one's kind of hamburger helper there. So let's break that edge and we'll do that test. So, all right, get that out of the way. We got a chamfer tool here. Let's just use this one. So let's, I don't really want to swat it on there very hard. Let's just do that. Let's just do that. Okay, cross your fingers, boys. we got here? Put that neutral. Well, it's pretty screwed up. I believe that's the chuck. So what do we got there? Since it's hard to read here. It's about 7 thousandths total run out. It's only 3.5 radially, but still, these Jacobs chucks will do better than that. All right, now I don't think. Let's actually, you know what? I'm going to get a chuck key and I'll tighten that, and maybe that'll make a difference. So lucky that one. Well, this isn't quite the right one here, but maybe I can get a little tighten on that. Let's see if that makes a difference. Nope. Is it worse? No, it's about the same. Okay. I don't know. What else? Wish I had the right key. I didn't scratch it. Okay. I don't know. I'm going to call this job done. I'm tired of working on it. Okay, so this is the last piece of the puzzle here that I wanted to kind of go over. And, you know, I don't know, everybody's going to run into one of these at some point or another, right? Is we've got a chowdered chuck, right? This female taper is garbage. And it doesn't register quite right on this. And it's chewed up enough that it's not a self-locking taper anymore, right? So how do you create the female version of what we did on this shaft here, okay? How do you create the female version of that, right? Okay, well, you know, we spent all that time, you know, aligning the compound rest, right? Well, now's the time to do something. You got all that time, all that time in there, and you can never ever get it back exactly the same as it was when you did this one, okay? So what do? So I'm ready, I want to do a female now. So I don't know, can you see that? Let's see if you can see that. Yeah, okay. So what I've got in here is I've got a left-hand boring tool, okay? And you remember that my compound is tipped in this direction, right? You know, because we were cutting a taper like that, right? Well, to cut a female one, you know, I would either have to swivel the compound over, or I can run the lathe in reverse, okay? And use my exact same setting on the compound, which is what we're gonna do here. So I got a piece of steel here, I've drilled a hole in it, and we're gonna go ahead and bore a taper that matches this. And now here's where a gauge comes in handy, because you just keep whittling away at it until it goes in up to that shoulder. And that's actually a very sensitive test, how far that taper penetrates in there, okay? And so we'll go ahead and, you know, I've over drilled it a little bit. I'm not going to worry too much about the depth. I'm just going to go a little bit past the 1 inch. But let's bore that out at that angle, and then we'll fit the, let's see, we got our sample. Although this has got some extra straight on it. We'll use this one here. We'll fit that to that, and we'll do a female version of that. Now, what you could do here is you're creating a good female socket now, right? So imagine just boring this out and press fitting a sleeve in there, and then reboring that sleeve with the correct angle, you know, to mate to the male taper, right? Boom, repaired chuck, right? So now this is not the super ball bearing type, but those super ball bearing ones are pretty expensive chuck. So if you could salvage one, that's probably a good thing. So let's go ahead and do that. Okay, so here's the thing that you always forget when you're working on the opposite side is you got to run it in reverse or it doesn't work. So, it's also got to be in gear. All right, so here we go. Okay, so there's one. Okay, all right. Let me get some high dollar toolmaker air. Okay, so we're gonna insert this taper. All right, and we can put a little mark on there. But basically, we're trying to get to that point right there, okay? Okay, so let's take another pass. Okay, so came up quite a bit. Let's see if we can see the difference in that. So there's the line I just made, and there's the line I just made, and there's the line I just made right before. Okay, all right, so it's not going to take much. Back to my starting place. Okay. Take about 5 thousandths out radially. Or, excuse me, that's diameter, 5 thousandths on the diameter. Well, really should. You know, any oil or any crud on there is really interferes with a fit check. So in reality, really, we should be really cleaning that out pretty carefully each time. Even a film of oil is not good on a mating taper. All right. Whoop, where'd I say? Oh, there it is. So my lines are gone, but well, I think we're I think we're done anyway. So, oop. All right. Well, now it's in there. Let's see if we can get that up. Okay. All right. Anyway, basically the idea was I wanted to illustrate that you can cut a matching female taper. You know, after you've spent all that time with your compound, you can make a matching female taper as well at the same time. So that's really the point I wanted to illustrate. And let's try our thing on here. Get this out of the way. There's the one we cut, and in she goes, okay? Well, let's see. Let me give that a little tap, actually. Let's, do I want to run that? There's my tapper. Give it a little seat here. It's pretty good. Anyway, I think you guys get the idea. So there's the conclusion of Tapers Ahoy. Thanks for watching.